Good morning, everybody. Okay, now good morning. We'll get started here in just a second. I'm almost ready. So as we go through today, if you have any questions, send them in using the Q&A box. I will not see raised hands. I will not see chat, most likely. I will see Q&A. There we go. All right, so without further ado, let's get started with today's webinar. Today we are talking about our Wi-Fi 6 products. So we've got a complete lineup of Wi-Fi 6 access points that we're going to talk about today. We'll start by talking a little bit here about the history of Wi-Fi. So the Wi-Fi standard was originally defined all the way back in 1997 with a max speed of 2 megabits per second. And basically, since then, we have slowly been making slight modifications to it, mainly focused on the area of speed. The core functionality and how Wi-Fi works has remained pretty much the same since 1997, with a few minor little tweaks here. Now, 802.11ax, on the other hand, is probably the first time that they've made really significant changes to the underpinnings of Wi-Fi and how it, in theory, is going to work. Specifically to solve a number of the issues that Wi-Fi generally has. So if you've ever joined my Wi-Fi 101 or Wireless 101 webinar, we talk a little bit more about some of the problems that Wi-Fi has, especially with today's modern usages of Wi-Fi, where it's being used for video conferences, online streaming, things like that, which is very, very different from how wireless networking was envisioned to be used back in 1997. So one of the big things here is a change from what we call contention-based Wi-Fi, moving to what we call contention-free. So basically, with Wi-Fi 6, there's basically no coordination of which device gets to broadcast at a time, and only one device gets to broadcast at any particular time. If two or more devices decide to broadcast at the same time, you end up with drop packets and interference. So Wi-Fi 6 solves that by giving the access point now the ability to be able to designate when each device is going to be able to transmit, taking the guesswork out of it. It also has some things in there which reduces interference between access points that are located within the distance of each other. And another couple little things that we'll talk about as we go on through today's presentation. So in theory, Wi-Fi 6 has the ability in the spec to get up to 9.6 gigabits per second. None of our products currently support that, but that's where the standard in theory can get up to. Basically, it's designed to have 4 times the capacity and performance. And Wi-Fi 6 upgrades both the 2.4 and the 5 gigahertz radio. So 11AC devices are still using 11N technology on the 2.4 radio. 11AC is only on the 5 gigahertz radio. So with Wi-Fi 6 now, both your 2.4 and 5 gigahertz radios can be operating and seeing the benefits of this new standard. Now, I should highlight here, for Zyxel, all of our Wi-Fi 6 access points have Wi-Fi 6 on both radios. Some of our competition in the marketplace, though, Ubiquiti is one example of this with their new Wi-Fi 6 APs they're launching next month. Those APs only have Wi-Fi 6 on the 5 gigahertz radio. So you're still using 11N or Wi-Fi 4 technology on the 2.4 radio of those Wi-Fi 6 access points. So something to keep in mind when you're comparison shopping. So the Wi-Fi 6 standard can do up to 8 times 8. So 8 different spatial streams, both receiving and transmitting, and has the ability to do multiple user MIMO, both upstream and downstream. So with 11AC, you could only do MIMO from the access point to the client devices. So with Wi-Fi 6 now, you can have multiple client devices transmitting at the same time without interfering each other using multi-user MIMO. We go up to OFDMA. So this is the new encoding standard. This has been borrowed from LTE in the cellular world. And it gives us a lot more control here over how the radio signal is being reused. We have what we're called resource unit scheduling. We've increased the QAM, which is the encoding, up to 1024 QAM. We have what's called BSS color coding, which helps solve interference. So basically when you transmit, your packet includes information on who that data is supposed to be sent to. So if your access point is picking up interference from users on a nearby different access point, it can help recognize that that information is not intended for it. And targeted wake up time, the ability to have devices essentially go to sleep and wake up at certain intervals specified by the access point. So OFDM is what's been used by Wi-Fi ever since 802.11a. And Wi-Fi 6 now gives us the ability to use OFDMA. So the primary difference here is how we're allocating channel usage. So basically when it comes to OFDM, you're essentially dealing with a 20 megahertz chunk of channel that can be used at a time. With OFDMA now, we've got the ability to use highly variable amounts of available airtime bandwidth for each device. So you can specify in chunks as down to as little as 2 megahertz. So your smart home plug, which doesn't need a lot of bandwidth, is only going to use a tiny amount of the available broadcast spectrum. Whereas something like your Fire TV, which is streaming 4K from Netflix, is going to get a bigger chunk of the available airtime. So when it comes to spatial reuse and reducing interference, as I mentioned earlier, we're using what's called BSS color coding. So this allows the basically more devices on different access points to use the same airtime without interfering with each other, because now the access point knows who it is that that data is for and can help differentiate interference signals versus signals intended for the access point. So if we look here at performance differences here, and in this situation here, we're talking comparing 11AC to 11AX, 2x2 clients. And what you see is 11AX has pretty stable aggregated throughput, no matter how many clients you add. So 5 clients, 10 clients, et cetera, across the bottom here. And this is your aggregated throughput. So you see, as you add more and more devices, the aggregated throughput stays the same. With 11AC products, as you add more client devices, the aggregated throughput goes down because you start getting these interference issues between the clients. So the individual clients are talking over each other because there's no coordination of who gets to broadcast, causing interference. So you end up using less of your available airtime as you add more clients onto the access point. And this is just showing here how much available bandwidth each client gets as you add more clients on there. And because this stays the same, you get higher throughput for each individual client. Same thing here, but this is using a 2 AP scenario where you've got 2 different APs both using the same channel. And same thing, as you add clients, the aggregated throughput goes down with 11AC products, where with 11AX, aggregated throughput stays pretty stable no matter how many clients you have operating in that area. So here's just a little sort of quick comparison between the different technologies out there. So you could see here, 802.11n had a maximum theoretical throughput of 600 megabits per second. 11AC Wave 2 has up to about 7 gigabits of theoretical speed that you could achieve, and Wi-Fi 6 is up to 9.6. And again, just like with Wi-Fi 4 and Wi-Fi 5, these speeds are the maximum data rate between the client and the access point. So it includes somewhere in the neighborhood of 40 to 60% overhead of the Wi-Fi protocol itself. So, you know, if you were doing a speed test, you would never see 600 meg, but you might be able to see 300 or 320, something like that. And then just showing here with the 2x2 stream, you would get a max 108 megabits per second on Wi-Fi 4, 900 megabits on 11AC, and now up to 1.2 gigabits per second on Wi-Fi 6. So I sort of alluded to this earlier. There's some situations out there where products are being advertised as Wi-Fi 6 that aren't truly Wi-Fi 6. And so basically what happened is we're still waiting for the standard for Wi-Fi 6 to officially be ratified. So we had vendors trying to rush product to market to take advantage of Wi-Fi 6 as a marketing term, start launching products as early as the end of 2018. although most of the products launched in 2019. So they were using chips that were based on an early draft of Wi-Fi 6. And because of that, the chips themselves, either the standard didn't have all these features fully defined yet, or alternately, it was just a matter of getting the chip to market. They didn't have time to implement these functions into the chip itself. So what you see is both Qualcomm and Broadcom have what are called Gen 1 Wi-Fi 6 chips, which launched in 2019 or late 2018. So these products are advertised as Wi-Fi 6. However, a number of the key features that make Wi-Fi 6 are missing from these products. So you will see this oftentimes advertised as a Wi-Fi 6 AP, but if you check the specs, you'll notice they don't do upstream OFDMA, they don't do upstream MU-MIMO, they don't do BSS color coding, they don't do TWT, all these features that really differentiate Wi-Fi 6 from the previous 11AC standard. So the chart on here is for Qualcomm. Broadcom is very similar. So basically, it wasn't until the Gen 2 chips launched, and there were Gen 1, Gen 1.1, 1.2, et cetera. So Gen 2 is really where you get the full Wi-Fi 6 feature set supported. And those didn't launch until very late last year. So at the end of 2019. So anything that's been out before that, earlier that launched before that, isn't going to support the full Wi-Fi 6 feature set. And there are still products being put out today that don't support the full Wi-Fi 6 feature set, just because these older Gen 1 chips are cheaper to get their hands on. So it allows them to go at a lower price point, but missing some of those key features. And again, as I mentioned before, some vendors such as Ubiquiti are launching Wi-Fi 6 products, but have only implemented Wi-Fi 6 on the 5 gigahertz radio, leaving the 2.4 gigahertz radio using the much older 11N technology. So here is our 11AX business AP portfolio. And this is going to stay pretty much the same for at least the next 6 months. I don't think we're launching anything new until maybe the end of the second quarter next year. So this is going to be sticking around for a while. As you can see, we've got 5 different models for you. So we'll start off with the first 3 products that we launched. The WAX650S launched in like January last year. The 510 and the 110AX launched in, I think, May or June of this year. So we'll go through and talk about the differences between these different models, and then we'll get to the new models. So the NWA110AX is a NebulaFlex device. So it's just like the Wi-Fi 6 version of the NWA1123 V2. It's a 2x2 radio, so you've got 2 spatial streams in both the 5 gigahertz and the 2.4. You have the ability to manage this directly as a standalone AP or using Nebula. And it follows the typical Zyxel design philosophy, which is to build these products basically like a tank. So there's no solid state capacitors to fail. We've got ridiculous amounts of shielding on the PCBA to stop EMI issues. We've got a giant metal plate in the back, which acts as a heat diffuser to pull heat off of the PCBA and the components and vent it out the vent holes on the top there. Heat fatigue is the #1 cause of failure in a solid state device like this, so that helps solve that. And we've also stuck in with our design philosophy of not mounting our antennas directly to the PCBA, but to move them above a heat shield and EMI shield off the PCBA, again, just to help that much more of a signal to noise ratio. And this is going to be true of all of the Wi-Fi 6 products we talk about today. So for those of you not familiar with NebulaFlex, Nebula is our cloud managed networking solution. It's available for free. So NebulaFlex devices means you have the flexibility of using the device as a cloud managed access point or using it as a standalone access point. You can easily switch between modes. You simply add the device, scanning the QR code on the device, and add it to your Nebula Cloud, and it'll automatically reboot into cloud managed mode. If at any point you decide to remove it from Nebula, it'll automatically switch back to standalone mode. So the WAX510D, very similar to the NWA110AX. We add the ability here of our dual optimized antennas. So dual optimized antennas, traditionally your ceiling mount antenna has a one fixed antenna pattern that it uses that's optimized for mounting on a ceiling. With dual optimized antennas, we've got 2 different sets of antennas built into the device. One that's optimized for ceiling mount, one that's optimized for wall mount. And you can easily switch between the antenna pattern when you mount the device onto where you're going to mount it. So that way you've always got the optimized antenna pattern for wherever you've decided to mount the device. And this is NebulaFlex Pro. So here again, very similar architecture, same design philosophy that Zyxel has on our business class APs. So this is just showing here the dual optimized antenna. If you decide to mount a typical AP on the wall, the antenna pattern basically shoots the signal up into the ceiling and down into the floor. So with dual optimized antennas in that situation, you can switch to an optimized antenna pattern for the wall. So NebulaFlex Pro, same thing as NebulaFlex, but we add the ability for this access point to also be managed via one of our wireless LAN controllers, whether it's our standalone NXC or it's an integrated controller in our Zyxel USG series of security gateways. And it also includes 1 year of NebulaFlex Pro. So NebulaFlex Pro is an optional add-on for our cloud managed networking, which unlocks a lot of extra MSP type features. So you'll get 1 year out of the box if you decide to manage this with Nebula. So again, really easy here to switch between controller managed, standalone mode, or Nebula managed. So we've got here the WAX510D. It's showing 2 of our competitors here, the Aruba AP505 and Ingenious here, either their ECW220 or their EWS357. It's the same hardware, it's just one's cloud managed, one is controller managed. So main differences here, you'll see here the Ingenious is not the true Wi-Fi 6. It's that pre-Wi-Fi 6 early chipset that they're using, so they're missing a number of the Wi-Fi 6 features. Aruba is full Wi-Fi 6, just like us. We're the only one here with the dual optimized antennas for that wall mount pattern. You can see we've got much better output power than our competition there. Otherwise, they're generally similar. So we did a throughput test here comparing the WAX510D with the Aruba. So the Aruba's in blue. Yellow is ceiling mount. Orange is our wall mount antenna. And you'll see here that, you know, even at various different distances that we tested here, we generally had higher performance than the HP Aruba product. Same thing on the 2.4 radio. So the WAX650S, this is sort of our flagship Wi-Fi 6 access point. You'll notice this is 4 spatial streams. So basically double the speed of the other 2 models we've talked about. This uses our smart antenna technology. It's got a 5 gig LAN port on there to help support the faster speeds that the 4.4 gives you. And this is also NebulaFlex Pro. You can see it also has a pass-through Ethernet port on it. So it should be noted here that this guy, if you're powering it with PoE, it requires 60 watt 802.3 BT PoE power. It does not work on the 802.3 AF or 802.3 AT PoE power standard. So you do need to be sure you're buying an injector or switch that supports 60 watts of power, or alternately, we do sell an AC adapter. Although generally there's not AC outlets up in the ceiling, but if you need to, we have the ability to power this via AC. If you plug this in and use it on a 11AT PoE device, it will still run, but it'll only use 2 spatial streams. So you're basically cutting your Wi-Fi throughput basically in half if you're not hooking it up to a BT PoE device. So again, similar technology to all of our other business class access points here. I won't go through all of this. So it does have our smart antenna technology, very similar to Ruckus's smart antenna technology. We've been offering this for quite a few years now. And basically it helps, instead of having one antenna pattern, which is what you run into with your traditional ceiling mount access point, or a dual optimized antenna pattern like we have on the NWA510D there. We have the ability with the smart antenna to choose between hundreds of different antenna patterns to help avoid interference and to focus the beam where the client device is. So you see here with smart antenna, in real time, we can choose from hundreds of different antenna patterns, and we take a look basically at where the device is in relationship to the access point and where other sources of interference are coming from, and then choose an antenna pattern to optimize directing the signal to the client device while also trying not to listen to other sources of RF noise. Whether that's other access points or a microwave like these show on this slide here. So it makes a huge difference in credit RF environments. Now, Wi-Fi 6 does have a number of technologies that we talked about earlier to try to deal with these denser RF environments where there might be sources of RF interference. Smart antenna technology sits on top of that and gives you additional benefits on top of the Wi-Fi 6 benefits. So you can see here, we've got a list of some of the competitors to our WAX650S. The Cisco 915, the Meraki MR45, Aruba 535, and the Ruckus R750. So you can see here that us and Ruckus are the only ones with the smart antenna technology. We've got higher output power than most of our competition here. All of us are offering 4 spatial streams. Us and Meraki have a dedicated third radio that just does Wi-Fi monitoring to make uses of DFS channels more seamless and less troublesome. Something for our Wireless 101 webinar, if you're not familiar with DFS and some of the issues that you run into with DFS and how a third radio would help, I go into that a lot more. Also, one of the few APs here with a 5 gigabit Ethernet port on it, making sure that your Ethernet is not constraining your data throughput. So again, we did some comparisons here, comparing us with the Aruba, and you see, again, much better performance. This is the 2.4 radio, and much more significant versus the previous 510 comparison, and that's because the smart antenna, some of the benefits you're seeing with the smart antenna technology, just increase that differentiation of what sort of speed you can expect to see between us and our competitors. So on the switch side of things, we have launched the XS1930-12HP. This is the ideal switch to use with the WAX650S. It supports 5 gigabit Ethernet on the WAN ports, and it supports that full 802.3 BT 60 watt PoE power. So this makes sure if you pair this with the WAX650S that you've got enough power to power multiple APs, and you've also got enough bandwidth throughput to be able to support the data coming off of those APs. So again, this here has got 8 ports that support up to 10 gig copper. And then we've also got 2 SFP ports and 2 other RJ45 ports here to help you as far as the backhaul connection or to link your switch stack together. So just to highlight here, differences between the NWA110AX and the WAX510D. As you go up here, you get the dual optimized antenna, and you go from NebulaFlex to NebulaFlex Pro. So you get the 1 year of Nebula Pro Pack, and you also get the ability to be managed via a controller. Then if we go up to the WAX650S, from the 510D, you're getting a dedicated BLE support, a dedicated scanning radio, smart antenna technology, double the spatial streams, and 5 gigabit Ethernet backhaul. So now the 2 more recent launches that we have here are the NWA210AX and the WAX610D. So we'll start with the NWA210AX. So this is a NebulaFlex device. It has 4 spatial streams on the 5 gigahertz radio, 2 spatial streams on the 2.4 gigahertz radio, and it's got a 2.5 gig LAN connection to help support the faster speeds of the 4 spatial streams here. So you see here similar design to our other business APs here. And then we've got the WAX610D. So same Wi-Fi configuration here, 4x4 on the 5 gigahertz, 2 spatial streams on the 2.4, but this adds the dual optimized antenna and takes us up to NebulaFlex Pro instead of NebulaFlex. And again, all of these are using that same RF design and hardening that we do on all of our business class APs. So the differences here between the 210AX and the 610D, going from here to here, you get dual optimized antennas, and you go from NebulaFlex to NebulaFlex Pro. So this is our full lineup here. These two models are our NebulaFlex, so standalone or cloud managed, and everything else on this side here, these are all NebulaFlex Pro. So they all include 1 year of Nebula Pro Pack and the all support controller management if you prefer to have a local controller instead of cloud or directly managing them. We've also with these introduced a new mounting bracket. So the mounting bracket itself has been optimized to be a little bit more flexible as to how you are mounting these access points. They now have the ability to be screwed directly into a wall or ceiling. They can be screwed directly into a rectangular wall outlet box or one of those circular outlet boxes that you sometimes run into, a junction box. So it'll work with all of those connecting properly directly to them. And then also if you buy our T-bar bracket kit, you can then also clip these directly to the T-bar instead of having to drill any holes to connect them to a drop ceiling. So we still have our Wi-Fi 6 to the max promotion going on. This is limited to stock on hand. So I'm not sure exactly what the supply situation is on these different guys, but until these sell out, this is still available. So basically we had bundle 1 here, where if you bought 4 of the WAX510S, you would also get a 12-port XS1930-12 HP switch, which would provide full power and speed to these. A second bundle where if you bought 3 WAX650Ss, you get a 4th one for free, but no switch included. And then also on the 510D, if you buy 5 of those, you get a free GS1350-12 HP switch. So like I said, this is available until these bundles run out, and you do have to buy the bundle SKU. You can't just buy them separately. There's a special SKU you have to use that is the bundles. So these bundles, you can find the part number on the price sheet that we send out every month. Or if you don't have that distribution, your sales guy should know, but if not, reach out to Jacob or David, and they can provide that for you. So that, guys, today ends today's webinar. If you have any questions, go ahead and send them in. I haven't seen any come in yet. And while I'm waiting for people to type stuff up, I do just want to draw your attention to the fact we do have an online forum for users to talk to each other, get help from each other, see what's going on. This forum is also monitored by our PM team and by our R&D team. So it's also a great place to provide feedback to them as far as feature requests, things you like, things you don't like. And oftentimes they will weigh in and respond to those requests or to feedbacks or to issues that you may be having. And then my email is up there on the screen. It's Sean R, SHAWNR @Zyxel.com. Feel free to reach out to me directly if you have any offline feedback. Richard has a question here. Richard is asking about outdoor solutions. So right now, we don't have any outdoor Wi-Fi 6 products. We have stuff coming, but it'll be later next year as far as dedicated Wi-Fi 6 access points. We also are working on a version of our outdoor enclosure that will let you take the indoor Wi-Fi 6 APs and mount them in a closure to make them waterproof for outdoor mounting. So that'll be available sometime next year. I don't have a clear timeline. I would hope that it would be Q1, but like I said, it's still up in the air, but that is coming. It's similar to the current outdoor box that fits the NWA 1123 and stuff like that. So it is coming. And I don't see any other questions coming in. I'll stick around for another few seconds here, but for everyone that joined us today, thank you. There is a contest today. So for those of you that sat through the bulk of today's webinar, there is a chance you may be chosen to win a $25 gift certificate. So that will be announced. I think the winner will be announced next week. Okay, and I'm not getting any more questions. So I'm going to go ahead and end today's webinar. If you do have something, just go ahead and reach out to me, Sean R @Zyxel.com, and I will be happy to answer that offline. Oh, one question just came in just before the buzzer. So Paul is asking, does the WAX650S have an option in Nebula for wall orientation? So for those of you, Again, the dual optimized antenna has the 2 antenna patterns, and you can switch between those 2 in the Nebula interface. In the case of the WAX650S, it's not using dual optimized antenna, it's using smart antenna. So basically, it's got literally hundreds of different antenna patterns it can use. Some of those are optimized for ceiling mount. Some of those are optimized for wall mount. And you don't need to worry about turning that on or choosing that option. It will automatically use the best antenna pattern based on where the client device is in relation to the access point. So it'll do that automatically. So there's no setting that you need to set. You can just mount it wherever you want to mount it. And there's definitely going to be plenty of antenna patterns it can use no matter where you've got it mounted at. Okay, guys, thanks for joining us today. Any other questions, just go ahead and email them to me directly. Thanks, guys.